Hello students, I hope you are all good. Today I have come with a very exciting episode where I would be discussing the very basic concept of projectile motion and a very simplified version where you can very clearly and simply solve the questions pertaining to projectile motion, because I am going to introduce some of the short techniques, quick techniques to break the problem, to crack the problem and access the solution in a very simplified manner. So let's begin with what actually is projectile motion. Before getting on to the projectile motion, I would like to discuss with you the very profound and prominent conclusions drawn by Galileo. Like they will take you by surprise. Like suppose this is a horizontal surface and we allow three different objects, and of course one thing we need to keep in mind is that they are all kept at the same height. This is something we need to keep in our mind. They are all kept at the same height. One body which is given initial velocity 0, which you call it is drop. Second body, it is kept at the same level, but it is we can say it is given some horizontal velocity of 5 meters per second, and the third body which is quite big, and of course it is also dropped from the same height. This is also having u 0. Fine. Even we can put it like this. We can put it exactly at the same level. Suppose a big body which is also dropped. Now this important conclusion which will help us is what Galileo has given. Let us say it takes t1 time to come down. This has been given some initial velocity 5 meters per second. So you are expecting it to travel or take a path like this, come down to the ground. This will come down like this. It will fall down, and this will also fall down like this to the same. Remember, they all are at same height. This is given some initial horizontal velocity. This is a very big, huge mass. So we say that the time taken by this is t2 and time taken by this is t3. And it appeals to our senses that they should be different. But what actually Galileo gave was that t1 is equal to t2 is equal to t3. This concept is going to help us very what you can say significantly when we are doing the concepts and questions of projectile motion. The time taken by first body, by the second body and the third body, it will all be the same. But remember, they should be dropped from the same height and same time simultaneously. इस चीज का हमें बहुत ध्यान रखना है कि they are dropped from the same height and same time, एक ही time पे. What is different for them? First body, it is given initial velocity in the downward direction. You can say velocity in the horizontal vertical direction is 0, and velocity in the horizontal direction is also 0 for the first body. For this, the velocity in the vertical direction is 0, velocity in the horizontal direction is 5 meters per second. And this is a massive body. It is also having velocity in the horizontal direction 0 and velocity in the vertical direction is also 0. That is what you call the free fall or drop case. And if you have referred to my previous episode where we have discussed the shortcut techniques for free fall, the same thing I am going to use. What time will they take to come down? It is obviously root h by 5. And you can see that it is independent of mass. That means what? Maybe it is big, it is huge. They are 1 kg, it may be of 10 kgs, but that does not matter at all, because the time taken to come down is root h by 5. I have done these shortcut techniques in my previous episode. That means it depends only on the height, and I am telling you time and again, they should be dropped from the same height simultaneously. So they will all take the same time. Now you may argue, why ma'am, this particular body is being given some horizontal velocity 5 meters per second. Why will it take, whereas it is having 0 velocity, it is having some initial velocity, why will it take the same time? Yes, let me tell you, even though it is having 0 velocity, it is having 5 meters per second, let me clarify here these things. What is the velocity in the vertical direction for the first body? It is 0. What is the velocity for the second body in the vertical direction? It is 0. So, vertical motion and horizontal motion are independent of each other. This is the fundamental primary concept of projectile motion. So, what you can see is this horizontal velocity. Now, what is this doing? You can argue at the same time that this body has got some extra velocity, whereas it is starting from 0. Yes. So, this is having some extra velocity, so it is covering some extra. Actually, it should have fallen here, but it is covering this much of horizontal distance. I mean to say, here the horizontal velocity is 0, vertical velocity is 0. Here the horizontal velocity is 5. This horizontal velocity is responsible for this horizontal distance. Vertical velocity is 0. These two cases here in this situation you can understand they both are similar. Here also we are having vertical velocity similar. So the similarity is in the vertical concept. And Galileo was the person who argued that the vertical motion is independent of horizontal motion. Here they all are having 0 horizontal velocity and they will take the same time t to fall through height h. If you understood it, then what would you call a projectile? How to define a projectile? How to define a projectile? Anything we throw and everything, anything we throw and let go. Means once we throw it, thereafter no supply of force. Anything we throw and let go is projectile. Now, let me ask you, suppose this ball is dropped with initial velocity 0, it is dropped, it falls down. Is it a projectile? Second situation, same ball is thrown with some velocity like this, it travels a path, comes down like this. And the third situation, suppose a bird, say parrot, colorful, beautiful bird is flying like this. Which of the situations would you call a projectile? Most of the times, generally, people think that this is a projectile because it appeals to their senses that it is having a trajectory of parabola or parabolic trajectory is something associated with a projectile. But let me tell you, this is even a projectile. This is even a projectile. This is not a projectile. This is not a projectile because it is a powered flight. Constantly, the parrot is, you can imagine its body as having some engine and constant supply is being given. This is not a projectile, it is a powered flight. But this is, once anything we throw and let go. Once dropped, we are not touching it. Once thrown, we are not touching the stone. So in both these cases, you say it's a projectile motion, whereas this is a powered flight. I hope you got the basic concept. Now let me do one or two questions with you, which will help us to grasp this concept in a better manner. Like, if we are given a situation, let me simplify the situation for you. Suppose I am having a horizontal surface and this is a tower of height say 45 meters. I am purposely choosing some figure so that it simplifies the calculation. Now I have got two balls. This is ball A and ball B. Fine. This ball A is given some velocity say 5 meters per second and this second ball B is dropped. Ball A and ball B. The second ball B is dropped whereas ball A is given some initial velocity of 5 meters per second in the horizontal direction. Keep in mind they both are at same height and they are released at the same time simultaneously. Now if I ask you how much it travels in the horizontal, I am asking you to calculate this distance. Let us call it r. I am asking you to find out what is the value of r. Now you may be wondering, how can I find out r when none of the other values are given? Now let me tell you. First let us do one thing. One thing I know from Galileo's observation that the time taken by ball B to fall down will be equal to the time taken by the ball A to fall down, as long as they are coming from the same height and they are thrown simultaneously. So they both will take same time. Why? Because horizontal motion, this is something you need to keep in mind, motion and vertical motion are independent of each other. Horizontal motion and vertical motion are independent of each other. Why? Because once you throw a projectile, we'll see, tell you later on. Okay, let us first solve this question, understanding that horizontal motion and vertical motion are independent of each other. So, I don't know the time taken by body A or ball A to come down, but I can calculate the time taken by ball B and apply it to be same for ball A. Why? Because their vertical motions are similar. Because this ball, I can say the vertical velocity is 0. Here also the vertical velocity is 0. So that way they both are similar. Now how to calculate this time? My favorite formula for shortcut of free fall, root h by 5. H is 45, so I get t as 3 seconds. Time taken by ball B is 3 seconds. And this is equal to time taken by ball A. So I've got the time taken by ball A to reach down, and I can calculate the horizontal distance is velocity into time. That is, velocity is 5 meters per second into how much horizontal distance will it cover in the time 3 seconds. So I get 15 meters. Means if it takes time 3 seconds to come down, that means in 3 seconds it will cover some vertical distance. At the same time, in those same 3 seconds, it is going to cover this horizontal distance. And this horizontal distance covered will be equal to range, velocity into time, and I've got it. Now one thing, why we have used this formula and we have not used the formula of acceleration, that is ut plus half at square, because in this situation, the force in the horizontal direction is 0. We need to understand. There is no force in the horizontal direction. Once you apply the once you throw and then thereafter you let go, you are not continuously supplying the energy to the body. So force in the horizontal direction is 0. Therefore, acceleration in the horizontal direction is 0. Therefore, velocity in the horizontal direction remains constant. There is no force in horizontal direction, there is no acceleration in horizontal direction, therefore velocity in horizontal direction remains constant, and I can calculate this. Now suppose I want to take another situation like this. I will discuss one more situation, and then we will, like suppose same horizontal level, two balls kept, this is ball A and ball B. Suppose this is given a speed of 5 meters per second and it is given a velocity of say 6 meters per second generally. They are pushed like this. They are pushed like in the two different directions. Like I am having two balls, I am pushing. Remember, simultaneously at the same time from the same height. So I have got two balls and I give them different velocities, simultaneously push them, and the height remains the same. So let us say it covers some distance and falls here, and it covers some distance and falls here. This height h is same for both of them. Let us call this as R1, this is R2. It is given that the distance R1 plus R2, let us say 220 meters. You have to calculate the time taken by the balls to come down. Take a minute and think, how will you move ahead? Nothing has been given, only their initial velocities in the horizontal direction and the total distance between their horizontal ranges is given as 220 meters, and you have to calculate the time they will take to come down. Very simple, yes. I will say, let us say, in order to travel down, they both will take time t is equal to h by 5. Both the ball A and ball B will take same time root h by 5 to come down. Now in this time t, they take to come down, how much horizontal distance ball A covers? Ball A covers r1 distance in the horizontal direction and it is equal to velocity into time. Velocity is 6 and let us assume the time to be t. Then ball B covers r2 distance in the time t. What is t? Time taken to come down. Time taken to come down. This is the time they take to come down. And when they come down, in the same time, how much horizontal distance the ball A covers? It is 6 times t. And how much horizontal distance ball B covers? It is velocity 5 into t. And it is given in the question that 6t, this is r1, plus 5t, which is r2, is equal to 220. It is given in the question. So we get 11t. I have purposely chosen 220 so that I get a simplified answer. 11t is 220 meters. So t is 20 seconds. This is the time in which both of them come down, irrespective of the fact that they have received different initial velocities. Last one question I would like to discuss. Like, suppose I have a tower, again my favorite number, 45 meters. From here, I throw a ball with a velocity of 4 meters per second, and at a distance of 10 meters, there is another tower. This is another tower. My question is, when it is thrown, it will come down like this. It will have a path like this. And where will the stone hit? Where will the stone hit? Will it hit the ground? Or will it hit at some height, let us say h dash from the level of the ground? My question is, this is a tower. The stone is released with 4 meters per second and it is coming down to a height of 45 meters. This distance between the tower 1 to tower 2 is 10 meters. Where will this hit? Either it will hit the base or it will hit at some height h dash. And where will the stone hit? So this is something we need to find, and we will do some more questions, little more complicated but yet done through a very, very simplified aspect. But the answer I am going to discuss in the next episode. Till that time, thank you, stay tuned.